Okay, Bismillahirrahmanirrahim. Let's discuss with the C++, stream classes and all that file stuff. And we have already seen the C studio.h, which is the C style doing files, like we have printf and all that. We have seen that last year. And I'm saying we're not using this, and we're using standard input output. We are using stream classes. So why are we using stream classes? That was the point we're discussing, right? Why are we using stream classes and not the C style file handling techniques, right? So I said there are 2 points. One, yes?
Types. Extensibility.
Yeah, one is type safety. First is type safety. And second is extensibility. Okay? Shatima? So recording for those guys who are absent basically. So what is type safety? The type safety is, let's give an example of this. For example, we got the main and all those things, I'm going to say int or whatever. Then we're going to say, for example, int I, and we're going to say character ch of size, say 40. You could say constant int I and all that, then you can use that, but not necessary. I equals 40 also. Now I'm saying fprintf, and I'm using standard input output, std out. I'm calling it std out. This is what we did last year. Okay? In fact, 2 years back. C. std out. Not last year, second year, right? Std out, and then I can say I, and I can say ch. Is it? This way we deal the std out. Means I been split 40 and ch and put that into this std out, and this is the way we deal with the file input outputs. But why we are using the IO stream type safety? This is not type safe. Maybe tomorrow you want to first put ch then put I. This will not work. This is fixed stuff. But in C++ we have overloading, right? The extraction and insertion operators, we have overloaded them to do multiple things. We have, for example, in IO stream, we have C out, I can say I. If I say C out, I can say, for example, somebody's name, NAME. For example, it was not ch, it was name, for example. And this is name. Now name. I am using same operator with the integer. I am using same operator with the name. Now this guy, is it visible in the camera? Sure. In this case, we are overloading this. Basically, this is calling an overloaded operator function, which is like this, operator. Okay, and then we're gonna say int I. Okay, and this guy is calling again the operator. Okay, but this time it is not. This is character asterisk. Okay, so this guy is overloaded. That's why it's working. The same operator is working with the integer. Same operator working with the name. So it is not immaterial. You call first I, then name or I, because they know which operator I have to call. Compiler exactly knows I have to. If it sees that it's a character with it, an array with it, it calls this operator. Okay, this is overloaded. You know overloading you have done? This is overloading. Okay, we can use multiple. We have multiple operator or overloaded functions for this operator. Left shift operator, right? Is it? It's already overloaded. As you see in the C, where is it for left shifting, and now it's using for the input and output in the stream. Okay, it's already overloaded. You know, we know that we have overloaded this. So its original job is not this thing. It is doing this job of input and output. Okay, it's basically giving this I to the C out. Okay, it's a standard output stream object, C out. Standard input object, C in. Okay, and now we are this I is given to that stream object, like C out or C in. Okay, but this is using the overload, like plus. We have already the plus, which is doing the addition. It can't do the addition of a class, but we can use that if we overload the plus. How we overload? Use operator plus and whatever function it should do. Are you getting me? And which function it has to call depending upon the signatures. Okay, signatures will actually tell us which function basically. That's what overloading basically means. Okay, it's an example of polymorphism. You can say it's a polymorphism. The same operator doing many functions. Polymorph means same operator doing many functions. Is it? Overloading basically is an example of polymorphism. It's a polymorphism. You know, when I say polymorphism, I say somebody like I, in front of you, I'm a teacher. The same Junaid in front of my parents is a son. Okay, same Junaid in front of my teacher is a student. You getting me? I'm again student. I'm joined PhD. So again in terms of PhD, so I'm again. I think I will be qualified. It's a good paper it was. So that means I'm again a student. Same guy, depending on different signatures, behave differently. So that's what polymorphism means. That's what operator overloading does. So this is type safety. You don't have to worry about the type. This guy will automatically do it for us because it is operator overloaded functions have written there. Where? In the iostream.header file. That's how we include iostream.h, iostream.h everywhere in the C++. Okay? Does make sense? The second thing is extensibility. Now, this thing is defined. Now you can but do much more. How? By writing your own operator overloaded function. For example, you may have a structure, and you want C out. Now we say C out I, C out the character, the floats, but not the user-defined ones. I want to C out the user-defined one, or I want to C in the user-defined one, the structure, like structure. We may have, for example, a structure struct, what other name is P, for example, it has many things, int A, or maybe it's a student. It's what? Can I rub this? For example, we have a structure struct student. Okay? And in this we got an int roll number. We got character name of size 30 or whatever. There are a lot of more things. And tomorrow I want to create of type student in a main. Student type variable S1. Okay? And I want to see out this whole S1. And I want to see into this S1. Only thing is, you have to write your own operator overloaded function, which will work for this structure. So that's what's called as extensibility, which was not in your C library stuff, C studio.h, where we use fprintfs and all that. If you use C style file operations, you'll be limited. What is there can do only that. You can't. You are also not type safe. If you do here and there, you can't. But in case of C++, we can. Does it make sense what I'm saying? Does it make sense? Okay. Now, if this is the thing. So why now we don't use the C style files? We will use what?
iostream.
iostream. Okay. Where is iostream? Teacher? Now what is in stream? Now stream is something which usually we call it's a flow of data. Is it like stream? Something is flowing. It's not an ocean. Something static or pond. It's a stream. We call it a stream. When we say something stream, it means something is flowing. So flowing from where to what? Where? Now if it is flowing where? From what to what? So it may be of yes, what?
इनपुट से जा रहा है आप तो फाइल्स में फिर फाइल से वापस डिस्प्ले हो रहा है.
That's probably one thing. From file to your maybe monitor. From a monitor
To file.
say for example keyboard into the file. But not necessarily it should be file IO. Basically it can be file IO, it can be in memory IO. Okay, we'll discuss a little bit that. But before that, I want to see the architecture of this stream. IO stream. Okay? So you have a stream, okay? this is not only, stream is not only just a flow. It's not a pipe. We say it's like a pipe, as comes in mind that it's like a pipe and where the data flows from this to that, but it has to do a lot of things. It has to do what? It has to do many things. That is why we have the layers of stream. There are 3 layers of streams. There are what? In a stream there are 3 layers. One's called formatting, second is called transport layer, and third is locale. You write down the layers of stream. Okay? Okay. So basically we have a program here. First thing, let me make a diagram a little bit. This is a program. Okay? Then there is a file. Okay? Then there is a display device. Okay, this could be your display device.
So formatting, transporting.
And there could be your, not necessarily this file, but it can be your network. Communication. So from here to here, from here to here, and it will get the file from there, right? In fact, both ways. Yes?
The formatting, transporting.
No, I will discuss that. I will discuss that. I'm making the first diagram. Make this diagram first. This is our display device to the program, to the network layer, or to the file. To the network, this could be communication channel. This maybe you can write here communication. Better word is to write communication channel. It can be anywhere. You're getting the file from anywhere. Not necessarily that you get it from the file which is in your system. You may get it from some internet. The stream, you know, your YouTube streaming videos. When there's a stream, there's a buffer. Remember that. That's automatic. When there is a stream, the buffer. So we will modify this diagram now. Okay, so I'm saying when there's a stream is a buffer. Without buffer, stream is not there. It is intrinsic. So you see YouTube videos, it's buffered basically, right? That's what, there's a streaming video. So that means you can get the data from anywhere. You can get it from file, different network, communication channel, or you may have in-memory I/O. That is, you do not have to get the things from file or somewhere else. That's there only in your system. Then you don't need the transport layer which we are discussing. I will discuss that. Okay, so I will modify this diagram now. You getting the basics right? Okay, we should have a clear idea what's it. A stream, then it's very fun to do. Not a big deal. So I am saying now we have in between a buffer. This is the big diagram we use. Okay, on one side we have a file. I should say program basically, right? I should not say file. This is a program which is using a particular file. Is it? Now here, this is the external devices. Now a file can be, this external device can be your file, which is which can be the hard drive basically. This could be communication channel. This can be anything. Okay, and this is the program which is trying to use that file. Your C++ program which is trying to use that file. Either it is reading from the file, or writing from the file. But you can't do it without the buffer. Okay, if you do not create a buffer, the buffer is created automatically. But you can create your own buffer as well. The buffer is always there. The stream is not without the buffer. Remember that. Okay, every time you stream, there is a buffer in it. Does it make sense? So now we have here on this side. Excuse me for making these bad diagrams. No? Call it formatting and buffering. Okay. On this side, I'm using the same stuff, but this is Okay. On this side, I transport and encoding. Now I'm in a better position to deal the 3 layers of IO stream. We have 3 layers of input-output stream. Number 1 is the formatting layer. Number 2 is the transport layer. And number 3rd is the locales. Okay? Is this visible? Does it make sense what I'm saying? Now, I've added the point that I'm saying that without buffer there is no stream. So buffer is already there. Always there. Automatically created for you. Okay? The buffer in itself is a class. It will have an object which will deal with this. That's why we have 3 layers. Now why we have 3 layers in IO stream? Why we have 3 layers? Is it? And the question comes, why is not a simple pipe? Why is it not a simple pipe? The data comes from here and goes there. It has to do nothing. Let the data come from here, input devices get it. But it's not like that. It's like an interface. Because the file on this side can be in such a format which have no use here. Right? On the program side, you need something which can be operated like this, but on your other side, the files can be anything. It can be a PDF format. It can be totally different thing. You can even say like, if the number is like this, 24.625, do you think the number is stored like this here? Yeah, we know. Floating point representations. IEEE? IEEE how much? 7554. That's totally different presentation. So who will deal with that? Who will convert this into the IEEE 745 format? This is the formatting layer. The formatting will do it for us. Okay? Now, the data may come in chunks, in slow. You don't, because on this side, if you want external device, this could be your hard drive, which we know is very slow. It's very slow. Okay? Now, we know that we have done the trade-offs of slow versus, but we have memory hierarchies, that's why, and we can keep it, this is a cost trade-off basically, that's why we have kept the slow device like hard drives in our system. Okay? So big, but very slow. Right? And we have done that, but we haven't mitigated the problem of slowness. That's why the buffer. We don't want to access the hard drive too often. And this is done with transport layer. Transport layer gets the things from external device into the buffer. When the buffer is full, only then this will be triggered. Hey, get it. Similarly, this one output, let the buffer be full first, and then transport layer will transport this into that. But there is not only buffer, there is also the encoding. Because this may be binary data, this may be character data, it depends what you are dealing with. Okay, we have to convert that. It may be PDF format, post document format, now it can be anything, any damn thing. The file can be in any damn, your file may be a text file, your file may be the Word file, the .doc, your file may be your PDF, your file may be .system file, .exe, .bat, batch file. Okay, well, thousands of files you have, maybe bitmap image. So don't you think it has to first convert into something that's understandable here? So you need encoding. Okay, so this whole thing is stream. Stream is not only a pipe. You get data from here to here. We have to do a lot of things. We have to do formatting. You just suit it. You may have negative number, but we don't have negative numbers. Say for example, we have two's complement format. Who will do that? Formatting layer, right? We have here totally different stuff. Let us encode it. And the buffer is basically used so that we don't need to access quite often the external devices. I'm gonna fetch it. Let it be full first, and in one go I will take the data. Does it make sense what I'm saying? Sure?
Yes, sir.
Good. So that makes our 2 layers, but thirdly, locales is how your formatting layer will do things. It will use what's called the facets. We have locales, where we have facets. We have what? Do you know formally how it does it? We have predefined facets, F-A-C-E-T-S. We have predefined facets, wherein we have put up everything how to do formatting. Okay. Similarly here, it will use again the facets of the locales. So the transport layer or the formatting layer are using the locales. In the locales we have what?
Facets.
Facets, and which will help us to do the task. Does it make sense what I'm saying now?
Yes.
Is the getting picture clearer, clearer, clearer? It's still a little blurred, but let me clear it more now. It is SD, not HD yet. You want HD quality picture, right? It is not that clear yet, so that you can jump into the program. Let's still see this, okay? Now IOStream has a wonderful class hierarchy. Okay? If you do a file program in C++, you will use iostream.h as well as you will use fstream.h. What? कैसा कैसा? अच्छा. Using more Facebooks on the tabs and all. Tak 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 look. Clear आसमान छा. रात के 2 बजे पार्टी अभी बाकी है. शौक ही नहीं रात ऐसी लड़के. I like it. Facebook, पता नहीं. या काम किस? What is that? अच्छा दिन जवाब वापस. मैं कमेंट है मैं उन्हें इतने कुछ वापस मान. तो नींद रही है. इसका अश्त खराब, नींद खराब, सोरी खराब. You see, Facebooks and all these are wonderful things actually, basically wonderful things to know what the world is doing. But our kids, I don't know what kind of kids we have these days. The culture is gone. Education institutions, culture is gone. Wherever we see, the culture is gone. Also, Nebrushan look like it. I was watching a video. He's a 15-year-old guy and he's good to school and he has built the, this is food for thought. That's a food for thought channel which actually shows those videos. He's a 15-year-old guy and he has built the HD printer and I'm going to say 3D printer, and then he has braille printers, printing for blind. Something comes in PDF format and the blind wants to read it. He has quit the school, he has changed the things. And outside world, they are doing like this. They are BCA holders and they are, it's not I'm telling you guys on it, I'm telling the whole system of our education. They are BCA and they do something where they jump into the research. They jump into the research, they do wonderful things. And here our guys are, parapadi, pose, yahan se pose, photo utha, Facebook pe laga, comments and all that. Isn't it? You see, our students reading, for example, they don't want to unravel things, they don't want to research, they don't want to do new things. Okay? So change yourself, I'm saying. Change yourself, do something where you are really will say that I have done something. You getting my point? Change yourself should be your New Year resolution. So this year, change yourself and try to unravel things and try to be something where you say that I have done this, this is my job, I have done this, the world is using this thing. And for that, you have to sacrifice all these nonsense stuff, wasting time. When you see the Facebook wasting time, just quit it. Just go. A minute you think it's wasting time, quit. Be mentally very strong. Otherwise what will happen is you will be a good student and you want to read, okay, but you are reading it and here comes the message on the ding ding and you say just मैं सिर्फ देखूंगा, and इस देखने के चक्कर में 1 घंटा कहाँ चला जाता है, इस देखने के चक्कर में दिन कहाँ चला जाता है, महीने कहाँ चले जाते हैं, you never know. Honestly, if you have to do a bold step, just delete your Facebook account and delete your whatever WhatsApp and all. This will be a wonderful thing for you. if you understand what I am saying. क्योंकि इंसान सोचता है ना वो बार बस नहीं मैं थोड़ा करूँगा, इस थोड़े थोड़े में इतना ज़्यादा हो जाता है कि आपका टाइम इतना वेस्ट हो जाता है और पता भी नहीं चलता बंदे को. Better is quick from all these things, but not WhatsApp because we are planning to read on WhatsApp, right? Anyways, formatting clear? Okay, you getting my point? Now we have to see the IO stream hierarchy. Okay, get it?
Yes, sir.
You thought of me? You can add up things in your note that will give you better marks also. If you add up these things in your note in exam, question may be something, but if you put the diagram like this and show something, it will give you better marks, right? I'll rub it now, huh? There are many versions of it. You should understand many versions of it because we had many versions of C++. It's come from the because we come from the C. Okay. Now there's the ANSI C++ going on, and there's also the versions going on. So there may be books. We may show different IO class hierarchy, but it's a somewhat general IO class hierarchy of ANSI C++. Okay. But if you say previous ones, if you have older book, for example, it will show you something like IO stream with assigned classes. But if you have a new book, ANSI C++, then it may resemble this. Okay, so first we have the iOS class. This is the base class.
Yes.
Okay. Okay. And we may have the iStream. Okay. We may have stream buff. We may have OStream. These are classes basically, okay? Then we may have the IO stream, which we are using often in our C++ programs. So iOS is the boss. Everybody inherits from this guy. Is it? And this IO stream inherits from both of these guys. That's why you are using IO stream. That means you want to do input as well as output. So C in, C out. You want to do both. Here we have C in, we have C out. Here you can have C in, right? And this you can have the C out, C and C log. Do you remember these two guys? Error, because we are not done error. That's not also in the syllabus, but there's a chapter of actually in C++, error handling techniques, where we can throw and catch errors. But basically we have the CR, this again the standard output. This is the standard error object. And C-log. C-log and CR basically are both same, they work for the errors, okay? But this is the buffer, it's unbuffered. Only difference is that. Even C-log is not that used much. CR we use basically. But in C-log, if we have multi-users and there's a big program where you want to see what was the error which came last time, and that error is basically buffered in the C-log. It is not a big deal. You can just simply write a program where you say CR, just like C out, hello, you can CR, hello. That doesn't matter. It is the same thing. I will show you. Okay. And iStream inherits everything. It has everything in it. But these will use your C out, C ins. But what about the files? Okay. For files, we have classes like I said input file stream, which inherits things from here. Okay. We have the output file stream, OF stream, which inherits from here. So whatever is in O stream, that is also here. So you can use C outs and everything, whatever there is, you can use it here also. Okay. And then there is the F stream, which has both things. So if you are using F stream, you can do input as well as output. If you are using if stream, F stream, input file stream, you can use only input to the files. You can do only output to the files here. But you can do both. Because F stream has everything, whatever it goes, everything goes into it. And there is also the F stream base class. Okay? And this guy inherits from this also. And F stream itself inherits from here. So F stream has everything. from iOS, from F-stream base, from F-stream, from off-stream, and these guys in turn have these. So everything is poured down into the F-stream. So if we are using F-stream, we can use any damn thing in a stream hierarchy. Right? Because it has everything there for you. This is the stream class, and it's called stream class hierarchy. What's it called? This is very important. You understand this, you are done. And there's one more thing called file buff, which inherits from, obviously, from here. Okay? So this is the basic diagram which you have to remember. Stream class hierarchy. Now you may see the old books which says here like this if stream. Then there is if stream with assign, or if stream with assign, and so on. Okay? But forget about that, just see this. Getting me? So this is my stream class hierarchy. Where we use, if I use F stream, it's everything we have. Now where is this if stream, F stream, OF stream which I need for the files defined? Because they should be defined somewhere, no? And I should include that. What do you think? Where will be that? Fstream.h header file. The fstream.h header file is the header file wherein these are defined. So before you do anything in your program, you should include fstream.h. And if I use the fstream.h, why should I use the iostream? Remember, iostream.h, fstream.h inherits everything from the iostream.h. Getting my point? So you have iostream.h, and we have what? Fstream. Everything inherits from into the fstream. Like your read line, get line, your get line function. Okay? That is written here, but you can use it here. That's inherited. But many things are inherited, many things are of its own. Fstream.h has many things of its own. Have you done this diagram? What are the its own things? I will go to the back, tell you what are the functions which are here in the Fstream, their own functions. It is like open, it is like close, these are functions, right? Then there is an is open. Is open is a function. It checks if the file is open or not. So that we can save, it can save us from errors. If it's already open, I should not open it again. Before I open, I can use the is open to check if the file is open or not. Because it's already open. If the file is already open and close is very simple. You open a file, I close a file. What we do with the opening and closing, I will come to that. Okay, we'll do the program of that, open and close. And I'm saying is open. If the file is already open and you're saying open particular file, that is an error. It's already open. How can you open the open file? So is open will save us from that. Okay, we have set mode function. Set mode. You may open the file in a binary mode or character mode. Is your file binary or is your file character? Is it? If it is your character file, you don't have to change it. But if it is a binary, you have to change the binary. You may have character file, but change to binary file, and so on. So set mode will set that. Then there is a set buff. Whenever you open a file, buffer is created automatically. I told you. Buffer is created, but you can create your own buffer using the. You can set up your own buffer using set buff function. Okay. Now we may have the RD buff, which will return the pointer where the buffer is. This RD buff will return the pointer where buffer is in a memory. You want to go into the buffer and see what is inside. It's the RD, which returns the pointer address basically of that buffer in the memory. Okay, and we have also the FD function in this file stream.h. What is that FD doing? It is the file descriptor. Every time you open a file, it has a tag with it, ID, identification for it, a tag, and FD returns that tag. FD knows what is the tag of that file. Well, you are opening a file, you show some number, identification number, it should have some ID, is it? And that tag is returned by the FD. And these all functions are where? In the
Extreme.
Okay, have you understood the basic story behind this streams?
Streams, yes,
Right? Now we should deal with the stream now. Let us open up a file now. Okay? I should do practically, but first thing is to understand few more things. Okay? The first thing is you open a file. What do you want to do with the file?
So it will automatically open the file when the object is called.
Huh?
It will automatically open.
How can it be automatically? Unless you may have thousands of files in your hard drive. How will it open? Which file to open?
When we call the function, so we get the object of that class.
But the thing is, you have to open a particular file. See, for example, Juni.doc is my file name. I want to open it. How will it automatically open it? How will it know? You have to tell him. You have to tell him which file you want to open. Now I'm saying you want to open file. What do you want to do with the file?
Read, write.
Read or write? Read or?
Right.
So you open a file in a read mode or write mode? But sometimes some people, some devices or something are read and write as well. Okay? So you can have, no, I'm saying your file can be, you can open a read mode only, that means you can only read from it, you can write. You open a file in write mode, you can only write into it. Right? Shiksha? Now, you want to do something different, both read and write, you can do that also, because we have a stream. Which can do read as well as
Right.
is it? So you can open the file in both modes. Is it?
Yes, sir.
So that means if you want to open a file in a input mode, for example, you need this class.
Input files.
If you want to open the file in a output mode, outstream class. But will you use the class or will you use something else? What will you use? You will use an object.
Object.
Will you do object or class?
Object.
Object. This object has the access to the class. So first thing is to create object of these classes. Input file or output file. So if stream or OF stream. Before we do this, we have to include what? fstream.h. We do what? We will include fstream.h. Is it?
Yes, sir.
Okay. Then when we have included both of these iostream and fstream.h, we have used we have included them. Now we need first to create what? Object of this.
This class.
And then associate that object with a file which you want to open or which you want to read from or write to. Isn't it? Simple story. The file cannot be opened automatically. How it knows which file you want to open? You have to give the name.
Names. When we call the object of such name, so it will automatically call.
Not object of such name. No. You're confused. File has a name. Okay.
Yes, sir.
You have to
Create.
associate.
That file into the
I'm
object.
using like Bangla or English associate, like Rashgulla. We have to associate the file object with the file.
Yes, sir.
The if stream object, stream class object with the file.
Yes, sir.
That can be done two ways. One is the constructor method, second is the open method.
Calling.
Okay? We have basically three constructors. These guys have three constructors for opening a file. For example, if I say like this. Can you read?
So क्या arrow होता कहीं गए थे?
Huh?
इसने inherit करा.
Arrows.
Arrow ना.
Yes, ulta. Sorry, arrows are wrong.
So, but sir, जो वहाँ
You have
पे
notations.
iostream.
Yes, you're right. Oh, arrow should be from this side because this is inheriting from this. Because this is Papa, this is
No.
Bacha. This is Bacha. So arrow should be that way. Okay, you can correct that.
So
Yes.
in this diagram, sir, ना iostream, sir, जी ना f-stream, iostream से कहाँ inherit कर रहा है सर वहाँ पे?
Huh?
वहाँ पे वो नहीं कर रहा है सर inherit. So f-stream है सर, वो iostream से नहीं कर रहा है वहाँ पे inherit diagram में.
Why you need that?
So वहाँ पे अगर है सर जब हम करेंगे F stream, it will have all the things of IO stream.
This is header file basically. This is not this is class.
Okay, sir.
This is header file where these are defined.
Yeah.
Fstream.x is header file
Header file.
where these are defined. These are classes. Okay? In a header file is something different. Okay? Does it make sense what I'm saying?
Yes, sir.
Okay. You can see the diagram from the book for these arrows and all. But the thing is that you understood. Okay, what I am saying now is you can open a file using constructor method or open method. If you have constructor, why we use open? We'll discuss that also. So we have basically three constructors. What? We have?
Three constructors.
Before saying that, if I say like this, I am saying output file stream, call it out or anything, whatever you like. This is an.
The name.
This is what?
Alias.
What is this?
The name.
Alias.
Object
Object or stream.
of this class. So web stream is a class. Don't get confused. Very simple. It's the same. It's object and making class of that. And if you are doing something with the object, that means it's calling what? A constructor. Isn't it? If you have a class student and if you have a student type something object and you're passing something to it, even if you don't pass, when you create an object, it will call what? Default constructor. And you're passing like this. That's what I said. I have created an object of this file, of this stream, and associated or associated, whatever,
File name.
with the
File name.
Unit.dot. I don't know why. With the associate, I'm getting a ball line. Somebody's knocking, right? Ah,
Yes. Yeah, मैं मता कर.
for the Bangla English, I got a cup of tea. Because Bangla people, you know, they are very sweet. Why? You know why they are sweet? Bangla people? Because they eat Rasgulla. Okay. Anyways, whatsoever. So I'm saying, do you understand my concept?
Yes, sir. The class and then the object.
An object, I'm creating an object associating it with this. But the thing is, why we use dot open function, not the constructor, is this out is tied with this file only. Now you want to read another file, say for example, cas.doc or any file. This out is associated with what?
Yes.
What's the pronunciation? I've forgotten the pronunciation. Associate. Okay.
Only with this.
On this start. So if you want to say no, I should not tie this out with the particular file, then you can do different thing. You can create off stream, type out, don't associate it with any other file. Whenever there is a file you have to open, use the out.open. Use what? For example, juni.doc. Now tomorrow you can, in the same program, you can say out.close. It deassociates this file, closes the stream, but do not kills the object. Remember that. The dot close doesn't kill the object. The object is still available. It only detaches this file from the stream. Okay?
इसको फाइल का नाम भी भेजना है ना साथ में.
यहाँ पे? No. It's only, I'm saying close it. When I'm saying shut down this thing, I don't need. In the open, I have to say the file.
अगर एक
अगर
दो
दो
फाइल
एक से ज़्यादा फाइल्स
open
Whatever it is, you can't open two or more than two files with the same object.
Only one.
Because object is associated with this file. Now at the same time, out cannot be associated with another file. You have to first close it. So when it's closed, it's by we know it. It is with this file only. I don't have to give the name. That's you getting me? Now if you want to associate this with another file, now you can because it is closed, but out is still alive. The point is the close doesn't kill the object. Okay? It is the destructor which will kill it. You have a constructor. You also have a destructor. You don't have to call it, it's by default there. It will kill the object at the end when it's understood the program is over and the object is no more. When the object is no more, so it will be destructed, right? Which deallocates the memory of the object. But the close only does one thing, it frees the stream. This file is not associated with this out object. Now out is free. That can be taken by anybody. Okay, you can say now out dot open another file junaid.txt. Keep it in double quotes, file name. Okay? But you can't do this thing with the constructor method. In constructor method, it's associated with the out and it is there. Does it make sense? So if you want to work with only one file, use the constructor. And we have three constructors basically. Now if you see the constructor of this, there will be two more things with this. If you see constructor of this, it is basically like this. It is whatever the off stream and this. I'm saying parameters, off stream out. There is the character asterisk. This is the file name, which this will go here. But there is the int file mode also. File mode, comma, int protected. The constructor is basically like this. Now you may wonder if I'm using juni.doc, I'm using only the file name. What will happen to these guys? These are basically the default. It will take the default values. This will take the iOS out, default value. Okay, we'll discuss them. That's called file modes. Because what? We'll deal with that. But I'm seeing that you're getting stuffed. You're getting too stuffed now. So buffer is full, I guess. It will overflow. So Juni.doc and other guys, I can use the file mode with it. I can use the protected with it. But I'm leaving that, so that means this will take the default values. Okay? Okay. So I'm saying I can use the open method also to open it, and I can close that later on. Does it make sense? I think we'll deal practically these things tomorrow. Okay? So
अगर कंस्ट्रक्टर के थ्रू ओपन किया, ओपन के थ्रू नहीं, इसका इसको करे close.
Yes, we can do that. That's not a problem. If the file will close, it's no more attached with this. Now, you can use the open method again if you want to associate with the file. Yeah, right. Good question. You have to close it. In fact, we should close it before. For example, you say why will we close? Because you don't want to only do the OF stream. You may use with this file. You open it now with the write mode. Okay. This is in fact the output mode. Not input mode. Now you want to open the same file, the input mode. You can't unless you don't close this object first. You do not because this is read only now. Okay, you want to write. This is actually we're writing this file. Using the out, we will write into this file. But now we've got modify things from this file out. We have the if stream. I have to first close it. So this file, agar aapki file is opened in the out mode, simultaneously it cannot be in the in mode because I am not using f stream as no f stream. If it's f stream object, I can use for both simultaneously. Is it? But if you use OF stream, now you can't use it for if stream. You have to first close this, then create, for example, if stream type object in, okay, and put it with this file and get things from this file. Very simple now, right? You copy these things, remember these things. Tomorrow we'll do programming on this, and we'll say file. We add this file modes and all. Okay, that's all for today. Okay.